Hey there, friends. Good afternoon. It is August 29th, 2023. We're coming to the end of summer. We have very, strong seasons here in the Pacific Northwest. So the advent of fall is being felt everywhere. And I start out here with some pictures from Portland just taken. I was returning from the Apple store downtown where we decided not to fix my Mac Pro because it's not really broken. It was just a question of can we get an even better battery, and we decided it's just not really worth it given there may have in the past been moisture inside, who knows? Like they have these sort of deep level tests. So we decided not to fix it. Anyway, scrolling back, I just wanted to show you some fall colors. Hawthorne Street Fair. I'm a big believer in what I call place based education, going way back in this channel, meaning I very often will localize, and I encourage others who are teaching in the style of the School of Tomorrow, which is how I brand, to do the same in whatever locale you happen to be in to the extent that you feel comfortable doing so. I think it really adds to a curriculum to have it localized and not really pretend to have that sort of God's eye objective voice that we're just kind of looking down on the world and we don't have to define who we are or what our ethnicity is or anything about us. You just need to take what we say at our word and not question us. That seems to be the other end of the spectrum from willing to localize, which is what I'm doing here, fall colors and so forth. Anyway, back to the content of today. Because of a spate of memos going about having to do with the Quadray coordinates, I'm going to just mention again where you can jump in here should you be interested. Should that be something that turns you on? 4D world gamer types, are you one of those? Because if you are, you might want to check out the IVM coordinate system, which is an alternative to everyday ordinary Cartesian coordinates as we learn in high school, all of us, right? Pretty much at the core of today's math. You could call it the sort of Minecraft or Lego world that we all grow up in of rectilinear XYZ coordinates. And I teach that stuff. I've been a high school math teacher and above and below and like all levels, right? And I'm not trying to discourage people from wading into 3D XYZ, then becomes extended linear algebra, becomes any number of dimensions, right? But that gets a little confusing if you're trying to shift gears and read synergetics because the namespace is different. The use of the word dimension tends to be different. And the quadray coordinates tend to be a good entry point if you're trying to break free of the sort of gravity well of the XYZ namespace and think a little bit different. So what we do in quadrays, for example, why are they useful? This is part of the memo. Is if you want to just do these kind of graphics, 12 spheres around one. That's what we'll call a one frequency. Here's C60 for real. Very reminiscent of Bell's kites, including suspending from a crane of some kind and used in the classroom by me. And then here's the part where I just do kind of a simple algorithm when we scroll down to it, where once I create the 12 directions from any ball, so say you're at any ball in this lattice, you have 12 neighbors, and they all have addresses relative to you. Say you're 0000, that's where you are right now, wherever you are. Then jump in these 12 directions to your neighbors, but then some of them you'll have visited before because we're going layer by layer outwards. So I keep track of the previous layer, all the balls in the previous layer, and I say, okay, find all the new neighbors, meaning if they're in the previous layer or we've already encountered them even in the current layer, then we don't want them twice. So there's a filter condition. If you're not in the current layer or in the previous layer, then add it to the next layer. And when you're finally done, you've looped through all the balls in, say, layer 6. Then you come back with layer 7. And you feed in layer 7 to get layer 8, and layer 8 to get layer 9, and so forth. And the only reason this works reliably is because all these balls have integer whole number addresses. Like their coordinates in the Quadray system, unlike in the XYZ system, don't need to be floating point. They could be integers throughout, as I'm showing in this chart. So this indicates ABCD indicates the Quadray coordinates, the first 4 columns, and then the corresponding XYZ columns on the right. Now, partly what's going on, I would say, is ChatGPT, because there's not a lot of information about Quadrays. There's stuff on Wikipedia, right? Quadrays on Wikipedia, let's go there. So there's some information here, there's some attached papers, there's a literature out there. In fact, the Math Forum had the Quadray papers. This was a whole sort of hub linking to other papers. Let's see, can I actually go there anymore? This is to the Wayback Machine, so this is not the current look of the Math Forum, but this is how it did look back in those days. This is back to, I'm not sure what this is November 2019, what we're looking at here. So Quadrays, okay, it's a literature, but as far as AI goes, it's only been able to munch through a finite amount by now, and it comes out with these hallucinatory statements such as developed by mathematician William Clifford in the 19th century, and later popularized by mathematician H.S.M. Coxeter. And what I'm saying in this memo is I'm guessing that this has something to do with, actually not this memo, but in another memo, let's see, where can I find the other memo? Let's go to TrimTab Book Club. TrimTab Book Club. I'm suggesting maybe that Clifford Nelson is another Clifford, and maybe the fact that he also worked on an alternative to Quadrays. Like, okay, here's the story. Synergetics comes out, but it doesn't really have anything to offer as far as an alternative to the XYZ Cartesian coordinate system. It talks about the IVM as kind of a competitor to XYZ, but where's the machinery? Where's the actual computational machinery? And Fuller doesn't actually seem to have that. And so Clifford Nelson, not William Clifford, another Clifford, worked on Synergetics coordinates, and he programmed using the Ada language, computer language. And he was posting to various listservs that I was on as well. And I was working with like Gerald de Jong and some other folks on what we called Quadray or Tetray, or David Chaco was the main guy for me. But there were other people in the background. From my point of view, right, I got it from David Chaco. But if you look on the Wikipedia page, I think we find the inventor is, see, where is the Wikipedia page again? Check it out. Go look it up. It may change again. I don't know. I mean, it's not that crazy an idea, Quadrays. I mean, you'd think that someone would have thought of it before now, actually. Quadray coordinates. And GPT gets it wrong, is what I'm talking about. It says it's William Clifford and H.S.M. Coxeter, and then it gives us malarkey here about how to translate from Quadrays to XYZ. And there is a way to do that, and it's in the source code that I've got for Python and all over the place. Like, we do this all the time. There wouldn't be a way to come up with this chart connecting XYZ and Quadrays if it wasn't for there being software doing that in the background. But GPT-3 is BS at the moment, right? It's phony baloney. And that's not unusual for AI, right? AI is a mixture of believable and well, it tries to be believable and sneaks in a lot of stuff that's just outright wrong. So you got to take it with a grain of salt. If you don't know the literature what you're wading into and you're relying on the chatterboxes to be your teachers, beware, definitely beware. So I wind up with, so why is this coming up right now? This is coming up because Andreas very kindly, at the end of a John Baez talk, asked something about this kind of stuff I'm into here, the quadrays and tetrahedral versus cubic thinking and so forth. And John gave a pretty cogent answer, I have to say. I'm looking for where he actually does this link. I know. In my reply, I give the background for other readers to understand, because it's confusing, that there are multiple namespaces involved. So it's at this YouTube recent talk by John Baez on his favorite numbers, 8 and 24, I think they are, and why and what all that's about. And he's very deeply steeped in kind of n-dimensional thinking, right? As is Andreas. That's kind of the realm of the PhD in math these days. That's where you have to go. And I'm all for that. Like, I go there too to some level. But there are other namespaces making use of this concept of dimension and taking it in a different direction, right? Treating it differently. So somewhere towards the end here, skip ads is where Andreas gives his question, and there's a really interesting answer, and this stuff is all very worth watching. I encourage you to, I'll put a link, and you can find where Andreas asks about, even mentions Quadrays, mentions my name. So I thought I'd kind of jump in here and say, this is what he was asking about, and in order to understand where we're coming from, you have to realize that quadrays are addressing the same space as XYZ coordinates. It's not like they're in different dimensional spaces. It's just one uses three tuples, XYZ, and the other one is using four tuples, i.e., four coordinates, one of them 0, right? In the canonical representation of all the spheres. And why I bring that up is because integers work better for this algorithm. Otherwise, when you wonder, have you seen this sphere before, and you look it up with a floating point number address, i.e. its location in space, if it's just one digit off, they're not going to be equal, and so it's going to keep the duplicate as unique. It's just, if you have everything coded as integer addressed, then you're going to have a lot easier time eliminating the duplicates, which is why my algorithm is so short and to the point here. I couldn't have written this Python code with this level of serviceability if I weren't operating in the space of integers. So we convert to the space of integers for doing work with these close packed balls, the CCP or FCC. We want them to all have integer coordinates, and that's one thing quadrays have proved good for. And then we can convert back to XYZ because they are interchangeable. That's the point. Completely, both directions. So you could say quadrays sit on top of XYZ, but you could also turn that inside out and say XYZ sits on top of quadrays. They're isomorphic, we could say. Not that I've done all the algorithms over again, but with Tom Ace's help and others, we do have a rotation matrix. We have all kinds of cool stuff going with the quadrays, so check them out if you're into math. New area of research, just you want to not be confused. Don't think you're getting into hyperdimensional Euclidean stuff just because you've gone to four tuples. That's not what's happening. All right, talk to you later.